All right, well, good morning, everyone. My name is John Snider. I'm a cotton physiologist with the University of Georgia here in Tifton, and it's my pleasure today to talk to you a little bit about cotton sensitivity to water stress. And I need to emphasize we're talking about too little water. There's various types of water stress. You can have too much and too little. But we're talking specifically about water deficit stress. And so what I want to do is just kind of refer to this. This is a table from back in the 70s. A lot of this was basically a review of literature where they looked at the sensitivity of different physiological processes, starting with cell growth. And essentially this author said this is the most sensitive process. So your stem elongation and leaf area are going to be affected first before a lot of these other processes. And right on down the line, basically, in terms of sensitivity to drought stress. One of the things I want to point out here, if you look at CO2 assimilation, this is another term for photosynthesis, okay? And what they show here, there's a really wide range, and this depends on species, and even within cotton, there's some argument as to how sensitive photosynthesis is to drought stress. And so again, this is an active area of research even still to this day. And so why do we need to study drought tolerance? As a physiologist, I like learning new things, so I go out there and we do a lot of measurements and use these instruments and kind of discover new things, and that's interesting. But one of the things I'd like to say is water is expensive. Now, from the standpoint, I've talked with some growers that say, well, it's not that expensive. I get good yield increases, and I don't have to pump from very deep, so it's not that expensive. But as was discussed earlier, I don't know if it was Calvin or George, but they were talking about competition between municipalities and agriculture, and then of course there's the ecological considerations as well, ultimately, that lead to regulations. Those regulations can require us to use more efficient irrigation technologies, scheduling methods, and then the other thing is, in some situations where regulation completely eliminates the use of groundwater resources for irrigation, dryland cultivation would be the only option. And in those situations, you would want drought-tolerant cultivars, again, in those situations. I'm going to skip over some of this just for the sake of time today. It was a little bit of a lengthy presentation. And with this in mind, some of the objectives over the past year were to quantify physiological and agronomic responses of some of the commercially available cotton cultivars here in the state to drought stress or to contrasting irrigation treatments. And then the second one, I'm going to take a little bit of time out here to talk because I hear the word thrown around a lot at different talks about photosynthesis. This is a term that's just thrown out there constantly. And so what I want to do is take just a second to explain what we're talking about here. Those of you, I don't know how much of the high school biology you recall, but essentially photosynthesis, we have some of the initial events, and those are those light-dependent reactions that occur in that first stage of photosynthesis, followed by the carbon fixation reactions that occur in that second stage. Those two things together are what we call photosynthesis, okay? And thinking of it in terms of, if you think of it in an economic sense, that's gross photosynthesis, okay? That can be limited by what we call photorespiration. Essentially, oxygen is sometimes used instead of CO2, and we actually burn, we lose carbon in that process, and that limits gross photosynthesis. Then you take that amount and you subtract the respiration rates from that, and that gives you net photosynthesis. And that's the one that's typically reported in the literature. Net photosynthesis is the net amount of carbon that's available for plant growth and development. So that's a pretty important one. But understanding how all of those other factors interplay to affect that is really important in future developments, whether we're talking about transgenic technologies or whatever we're talking about. Certainly this is often, I would say, in the future, but essentially we need to understand some of the more sensitive mechanisms to drought stress. And then this last thing here. We can measure a lot of things. We can measure plant water status out in the field. We can measure indirect measures of water status like canopy temperature. But then the question arises, well, we can measure this, but can we use that to predict a response? Can we use that to look at drought tolerance and drought sensitivity in cotton? And one way to do that is to use a valid measure in season, in this case net photosynthesis, as I discussed earlier. And so that was the final objective there, was to look at how that responded to these different measures of water status. So this was addressed at the Strickland Irrigation Research Park in Camilla, Georgia, so you've heard about this already. And there were 3 cultivars. Those of you who want to see differences in cultivars today are going to be a little bit disappointed, I'll just tell you right now, because essentially the data has been pooled across all these cultivars, and I'll discuss that a little bit later. There were 2 irrigation treatments, the dryland and the checkbook, which has also been mentioned. It was a randomized complete block design with 4 replications there. And just to kind of give an overview here, this is just showing the checkbook method. Again, this has already been mentioned today. And then here's the total amount, rainfall plus irrigation. Of course, in the dryland or rain-fed treatment, whatever you want to call it, we had 17 inches total, and this was from rainfall. And then rainfall plus irrigation, we had about 24.3 inches total. Here's just some things that I want to go over as far as the measurements. I'm just going to try to skip through these. In this picture, this is just showing we were doing infrared canopy temperature measurements with that infrared temperature gun there, thermocouple measurements of leak temperature. The blue box, this blue box is called a Scholander pressure bomb. The pressure bomb, the only thing it measures is water potential. And so pre-dawn water potential represents the water potential of the soil in contact with the roots. Okay, that's what pre-dawn water potential represents. Midday represents the water potential of the leaf at the time of measurement. Okay, in other words, the midday is just the actual leaf water potential. This device right here is a chlorophyll fluorometer, and there's all these little values here. What I will say is those first events that I just talked about, those electron transport events in photosynthesis, those ones can be measured with this device. Okay, that's what you need to know. This green box here, it measures CO2 exchange. All right, the CO2 exchange rates give us net photosynthesis, and when we combine these two together out in the field at the same time, we can get those values of dark respiration, photorespiration, gross photosynthesis, and all of those parameters and how they interact to influence net photosynthesis. All right, and then down here, these last 2 little values, those are stomatal conductance and transpiration. Transpiration is water loss, basically evaporative water loss from leaf surfaces. All right, I'm going to skip over some of the data. There was quite a bit of data, so I kind of need to jump through some of it. But if we look at the pre-dawn, and you need to understand, I'm presenting data that we have all those measurements on those sample dates. Okay, obviously, here, let me back up. On some, one of the things that limits our ability to get a substantial amount of data is midday stuff. If we want to get measurements at midday, it's influenced by sunshine. I mean, that's no shocker there. In South Georgia, we seem to get consistent cloud cover almost every day. So, there's a lot of pre-dawn data that I'm not showing here. I can go out and I'm not impacted by cloud cover. But the midday stuff, we had a few good sample dates, and so I'm presenting all of that data here. And what you can see is definitely there's a difference between the treatments, the dryland with those open circles there. We had lower pre-dawn water potential, and in all sample dates we had lower midday water potential under dryland conditions. All right, if you look at net photosynthesis, obviously we had a very big difference here in response. So where we had our lowest water potential, we also had the lowest net photosynthetic rates, gross photosynthesis. Dark respiration, this was a little bit of a debate that dark respiration may increase or decrease under water stress. We're reporting a significant decrease. That doesn't look like much, but as a percentage, it is a pretty substantial percentage decline under drought stress. Photorespiration, we can see that increased substantially. So if you recall, that's a carbon loss mechanism that limits our gross photosynthetic rates here in B. All right, this one, there's a lot of things here, and I don't want to spend a lot of time on it. All this is saying, okay, all this graph tells you is that photosystem 2, those initial events in photosynthesis, are not negatively affected by drought stress, and if anything, they're somewhat positively affected by drought stress. So that is not an area we need to be looking to improve tolerance, since it's already extremely tolerant to drought. Okay, so that's one thing that we can kind of gather from that. Some of the gas exchange parameters, the remaining ones, the transpiration rates. You see obviously a bigger difference between the dates, and that there's so many parameters. Wind velocity, among all kinds of other things, that can impact transpiration rates. But obviously in the dryland we have much lower transpirational water loss. We have substantial decreases in stomatal conductance there, and lower water use efficiency, because the net carbon that we're taking in, we're actually losing more water, so it's actually less efficient under those drought stress conditions. This was just another way to look at that respiration data. Just to show you, depending on how you look at the data, it will influence your interpretation there. If you look at dark respiration, we looked at it as a function of leaf area. We saw that it declined, okay? But of the total carbon that's being fixed through photosynthesis, what proportion of that are we losing due to dark respiration? Okay? And what we can see is, in that sense, dark respiration as a percentage or as a proportion actually increased under drought stress conditions. So that's another way of looking at really at the same data. And then this is the part where I talked about measuring water status, but how does that relate to something biologically meaningful in the field? And what this would show is that yes, we can predict, if we have measures indirect, this is canopy temperature here in A, this is the pre-dawn water potential, and this is the midday water potential. And what we can say here is that we can predict with some degree of certainty where photosynthesis begins to decline. So if we look at water status, there's a point where photosynthesis starts to drop off. This is the midday data here, okay? Obviously, we'll have more data points next year. And you need to understand, each dot is an average of 12 replicate plots there, okay? So it's not just one data point. But anyway, so this is, these are things that we can use. We can predict responses and use them to detect really drought sensitivity. This could be overlaid with something like those sensor-based measurements, where you say, well, here's a point that we're seeing a decline in photosynthesis. What are our soil moisture sensors telling us at that same time, right? So, because no one wants to get out there and do these hand measurements, but you could use it as a means to identify your appropriate triggers. All right, and then so you measured all these things. What does it mean in terms of yield? Obviously, we had a pretty substantial yield difference. And this is the average. We had an irrigation treatment effect. We didn't have interaction between varieties in irrigation treatment this year. And so just overall, photosystem 2 is not that sensitive. Those primary events are just not that sensitive to drought stress. Photosynthesis is, and this is related to increases in the amount of carbon losses due to respiration as a proportion, but also photorespiration increases under drought stress. The other thing here, there was no interaction between variety and irrigation treatment. So what does this mean? I mean, there's no difference between varieties. It means that this year there wasn't, and either there are no differences between these cultivars in terms of drought tolerance, or that the stress wasn't severe enough to detect the difference. So those are our options there. And then, of course, these measures of water status were indicative of water stress. Again, what I want to point out is pre-dawn, even though no one likes getting out there before daylight and getting these measurements, I don't have to worry about cloud cover, and I can consistently get good data out of this. And then obviously, yield, the irrigation, obviously this translated into lower yields. So with that, I'd like to thank the University of Georgia, the Georgia Cotton Commission, and everyone who has helped with this project. Dudley's not in this picture. I do mention him there, but he wasn't there when we took the picture that day. Dudley's back there, so I'll at least acknowledge him as well. But anyway, so just I'd like to thank everyone involved in this, and I'll be happy to take any questions that you may have. Yeah. Yeah, so what we're saying, if you look at the checkbook, if you do the math on the checkbook, we had just a small difference between what the checkbook would tell us our cotton crop needs and what we got in rainfall, right? So we got this huge difference in yield. But what does that mean? I mean, really, there's certain water losses that if you have really heavy rainfall events, not all of that rainfall is being used, right, it's going to do the crop any good. So there's a certain amount over that is actually not being used by the crop. But if you just look at the total over the course of the growing season, yeah, there's only a 1-inch difference between that and what the checkbook application would be, and we have huge yield differences.
Plus timing.
And timing, timing's the other thing, absolutely. So, early on, and that's one of the things you saw those crop coefficients early on, really it's just whatever water is evaporated from the soil primarily. And if you're getting lots of water on the front end there where it just isn't needed, then obviously that you'll have problems later on. So. All right. Yes.
Canopy temperature. We're hearing a lot about canopy temperature sensors.
Yes.
We're testing them.
Yeah.
What are your thoughts on usefulness in terms of irrigation?
In terms of irrigation. I like that you can collect so much data because those sensors are near continuous measurements, and I talked a lot about this at the Belt Light cotton conferences as well. As you saw, there was definitely a relationship there between temperature and net photosynthesis, but is that a temperature or a water stress effect, right? But that, again, what I would say is that there is a relationship between water status and canopy temperature. Okay, that relationship is going to be different here in Georgia than it would be in some place like Arizona. If you have drier air, essentially the plant can have greater evaporative cooling capacity and be lower than the air temperature. All right. If you have more humid air, then the leaf you'll actually have higher temperatures. Okay, so it's interesting. When we talk about temperature, we need to definitely be using canopy temperature as the measure there, but we also need to take into account things like vapor pressure deficit at the same time. And that's something that was measured in the study as well. I just kind of skimmed over it. All right.